I guess let's get going with our massive crowd for today. Got at least a couple people who said that they couldn't make it, and they'll be either now or later. Yeah, we really only have one class left of our main class. We're going to do the extension afterwards for anybody who wants to move on to the Rails course. Also, we sent out, both of us sent out calendar invites. So people, yes?
It's scheduled for you at 12, but did you have it with
No.
Maybe
Today?
Yeah. It's fine by me. Anybody who hasn't taken the opportunity to put something on the calendar, just take that chance. Take the opportunity to talk to us about what you got out of the class and what we can do to improve it. I know that there's areas. I know that the area that I've already highlighted for myself is the next time I do this, I'm definitely going to have a more formal process for giving feedback on the work that students do so that I take a look at the code and give direct feedback as opposed to it being more open-ended. I think that would be a better experience for the students to actually know that they're progressing and get some input on their code. But beyond that, just take the opportunity to talk about where you want to go and what you're interested in. That's really what we're looking for out of those one-on-one meetings, is to hear your feedback and hear your story a little bit. So let's see where we're at. Coming up to the end of this, we've talked about classes. We've started to introduce these concepts. We haven't introduced everything around how to construct stuff in Ruby, but we started with some basics. So let's do a review, as we always do, of some of the stuff that we went over last class so that we can help get it back into our minds. And then we'll talk a little bit about modules, the concept of modules, what they are used for, give at least one example. I'm sure that Jorge will be able to help me out with better examples or more, because it's a very common pattern in Ruby. It's something that not all languages have. Again, talk a little bit more about scope. Remember, we talked about scope back when we introduced the concept of functions or methods originally. Now we'll talk about scope in a larger scope of classes and objects and methods and how scope interplays with all of that. We'll probably just touch on private methods, private variables, anything along that line. And then I think that'll leave plenty of time for us to try and live code out more, if not quite all, of the tic-tac-toe example that we're trying to build out, so that we have something that feels more complete than the smaller programs that we've written so far. So start off, quick review. We introduced the concept of class methods in the last session. It's hard to use words that don't have multiple meanings within the programming language and say stuff. So we introduced the concept of class methods. And class methods, as opposed to also class variables, are different than instance methods and instance variables because they're attached to the class itself. They're not part of, if I do a person.new, they're not part of that object, they're part of the class. And the power of being able to have some of these class methods and variables, it gives you the capability to do things like have additional initializer type or new type methods that'll let you create an object with a different piece of structure than what the default person.new would be. Maybe we can do a person.fromString to get it from a specific formatted string. It also allows you to have the class maintain information about maybe objects in the class or what's going on. So they're very useful, but they're also a little bit of a challenge to think about because it's hard to think of this class as an object itself that has its own behavior. It's easy to think of it as something that just creates stuff, like a factory. It just puts something out. But it is also an object with its own capabilities, its own function. And that's what we're doing with class methods. The way we distinguish them from instance variables or instance methods is that if you use the at directly inside of your class as opposed to inside of a method, like or an instance method that you would have, that's going to be attached to your class and not attached to an instance of the class. And then to reference or to create a class method, you use self dot when you're defining it. Self is this magical concept in a sense in Ruby that says, I am referring to the object, whatever that object is right now of me. So since we're in the process of creating a class, in this example, self means, oh, the class, that's what it is. Whereas if you've created an instance of a class, an object, then inside of those methods or other things, self refers to that object as opposed to the class that was creating them. And then inside of any self dot type methods, if you use the at syntax, which would normally be used for referencing an instance variable, that syntax is used now to reference these class-based variables. And if you're inside of, say, an instance variable or an instance method, or you're outside of this class entirely, the way that you reference it is using the class name and then the name of the method that you're trying to access, because it exists on the class and that class is an object itself. Does that generally make sense? Think so? Again, it's not something you're probably going to write every day, but it's very useful to understand that they can exist. The other concept that we introduced last time was just inheritance, the concept of how to inherit inside of Ruby. And inheritance you are going to encounter. You're going to encounter it a lot. You'll also see other ways to build objects, but inheritance is still a very, very powerful tool, very common pattern. So you need to be comfortable with it and get a feel for how it works. Inheritance is just the concept of one class inheriting the methods and variables from another class. In this case, we have a square that's inheriting from the rectangle. And because of the square inheriting from the rectangle, we can initialize it differently, calling up to our parent or super classes initialize using the super. But that square, any square objects that we create also happen to have an area method on them because it has access to everything that came off of its parent class. This is a concept. It takes a long time to get really comfortable with this idea of how this works. But you need to start thinking this way. And we can give, we've given a lot of examples over the course of the class, bit by bit of this. And a lot of it are the items built right into Ruby, where, do command, there we go.
Remind me how does super actually behave? Super just goes up and calls the method on the top, on the parent class? Is that what super does?
Yes, I believe.
Yeah, well, because otherwise Ruby within the current class for the method you're talking about, it looks there first, and then it kind of gradually it goes back to see what method you're talking about. But if you say super, it will physically look at that class. They'll know this is the parent class.
Yeah, it's a way, you can think of it as an escape hatch, in a sense, to explicitly go up to the super. It has a little bit of magic with it, if you will, right? Like if we're looking at this example here, again, inside our initialize on our square. So if we created a square off of this, and we can, there might be somebody else down there, let me see. Nope. If we created a square off of this, an actual square object, let's just go ahead and create these. And then we did what's actually happening during that creation is that it's calling the initialize for our square And super will look at, when you call super, it'll say, oh, I know I'm inheriting from another class, and I know I'm inside of the initialize method. So now go to my super class, rectangle in this case, and look for its initialize method and call that with these parameters. So it's a little bit of magic going on there, because super, if we had super in a different method than the initialize method, if instead we had it in the area method, for example, then it wouldn't call initialize on the superclass, it would call area on the superclass. So super is a way to explicitly call that method on your parent object, what you inherited from. But that can also implicitly call the method on your superclass. And that can happen in a lot of different scenarios, but the most common is the method just doesn't exist on your class. So in this case, this puppy's dying, the square.area, well, there's no area method on our square object. It doesn't exist. So implicitly what Ruby does is it then says, oh, if it's not here, I need to look at the superclass, the rectangle, and see if it's on this rectangle instead, and if so, I'll call that. And that's one of the really powerful aspects of inheriting from another object, is that if you can rely on the same behavior, then you don't have to redefine the methods on your new inherited object. You can just use the same methods that existed on your other object. I don't think there's anything else there. So we'll look at some more examples of that today, but there's a lot of examples of built right into Ruby where you have objects that are calling down to methods of something else. Here we have foo, and we know that its class is going to be a string. And we know if we look at methods, we're looking at every method that it has. This isn't a list of just the ones that are on the string object, but it's a list of every method that it's inherited from every class that it inherits from. And some of those are going to be just on the string object. So I suspect, say, downcase or upcase are probably just on the string object. So if I did foo.methods minus foo dot, how do I get it? Is it super class?
Yeah.
Dot methods? Oh, class, yes. Class first. You can see that it's a smaller list that we have down here, but a lot of those methods were defined just on foo, or just on the string class. But if we look, we'll be able to find something, I'm sure, that is defined lower level. Let's see here. Might actually be easier to do. I don't know if this will work. This might be crazy. Probably not going to work, but we'll see. Yeah, all right. Cool, cool. So these are the methods that if we call down to them, it would call something on one of our superclasses and not on the string object itself. These are all going to be very non-standard things for us to call down into. What we could do, singleton class, for example. Come on. That was weird. What's that?
Do you need it?
All right, I don't know. I give up on that. A better example is probably a number anyways. So if we did foo is 42, and we did foo.class, and you have fixed num, foo.class.superclass, that's an integer. And if we look at the methods on that, you're gonna see a lot more methods, most likely to exist on an integer or even on anything like that than you would with what we had up above.
Interesting.
Yes.
There's a lot of, yeah. There's a lot of methods that you're gonna see when we list methods like that are aspects of working with objects that you probably would never call directly. They're tied into the idea of making sure that your object is correct, that it hasn't been changed. There's also some that are functionality that you probably wouldn't need to use. For example, it looks to me like some of those methods that you'd run across are things along the lines of a method you might call to lock in your object at a certain point in time, and then check and see if it changed later. To say, oh, has anything happened to this object to change what it was from the last time I expected it to be here? So you're going to encounter.
See if it mutated at some point.
Yeah. There's a lot of these sort of low-level functionality that you get in this, and we could go through them all. I probably wouldn't understand what all of them do, but I could understand, I bet a decent number of them do by looking through them. Let me try what I did the other way again. foo.class.superclass.methods minus foo.methods. Oh, this isn't going to work the way I want anyways. Because it should get rid of everything or darn near everything out of it. So there's just something a little funky on the way that that's working. Anyways. Just trying to look for a good example here. I don't feel like any of these are particularly good examples. Yeah, I'm just out of it today. is good. So that's inheritance. I feel like I sort of bumbled on that. But the concept is that you want to reuse behavior, reuse functionality, and reuse structure and definition. So sometimes you'll override behavior and function. Sometimes you won't. Sometimes it'll be the same, but you're using it to reuse structure. In a lot of other programming languages, you'll have the concept of something known as a interface. And when you inherit interfaces, that's more just defining behavior versus defining what that behavior does. And Ruby doesn't have a distinction between the two, so you end up using inheritance both to define what would be an interface and to define what would be actual behavior. So in Ruby, I think it wouldn't be uncommon to have a class of shape, for example, and in that you might define a method of area, and maybe it doesn't do very much initially. It has a really complex computation because you have to do it in the most generic, complex way. And then you can define a class of rectangle, which inherits from shape, and it's going to define an area as well. That one's just going to return width times height. That is weird. Superclass mismatch. For class rectangle. I don't know what that means. I'm just having a fun day today, aren't I?
Look it up because I've never seen that.
I'm on it. Superclass mismatch for class. You already have a word class defined elsewhere. So what's going on is it allows me to monkey patch, but not allow me to monkey patch a new inheritance chain, it looks like. So since I had already created a class rectangle here, if I did it now, I think it'll work.
This rectangle inherits from somebody from Square, right?
Yeah.
And so you're trying to inherit another thing.
Yeah, it inherits from object or whatever, and I tried to change its inheritance chain, and it was like, I can't do that.
Yeah.
You can change some of the stuff internally, but you can't change its inheritance chain. That looks like what happened. So that time it's happier. Now I can now change what a shape is and change that behavior. So if I did class shape and I add something else new, def, we'll just say type, and we'll put self.class. That's not going to work now. Now it's going to be angry. Class shape, def type, put self.class, end. If we create a rectangle, except we've got a problem here, don't we? So let's make our rectangle actually initialize correctly. I don't know if I have to tell it how to inherit again. I'm doubting it. Initialize width and height. Rectangle.new 3.5. All right. Now I have a rec.type method that also exists. We can still add stuff to the lower level classes and objects. And it just called right down to the type on the shape object instead of ever finding it on the rectangle itself. But there's another way to share functionality between objects in Ruby. There's quite a few, but another very, very common way is what's known as a module. And that's one of the new concepts we're going to introduce today. A module is a way to share functionality, but not share instance variables or other inherited type behavior. It's more about sharing methods and sharing this type of common logic. So you'll encounter modules a lot in Ruby, and another term you'll see used for them, although it's in a specific case when you use it, is a mix-in. So when you use a module inside of an object, it's known as a mix-in into that object. And I'll show you an example here, and I think it should be decently straightforward as we walk through it. But I'm going to grab all this code, and we'll put it over in the IRB.
So they cannot be instantiated.
Yeah, we'll talk about that a little bit. So module is distinct from a class or anything else. It's its own type in Ruby. You have a module, and then you give it a name. Your names are going to look like what you would do for a class. You're going to usually do an uppercase name for a module type structure. So in this case, I chose greetings. And what this module has, it just has a couple methods inside of it. It has hi and it has bye. It just puts something out on the screen. But then the powerful aspect of a module, at least when it comes to working with objects and classes, you can use stuff off of modules in a lot of places. You'll find modules that have just constants and other things on them. And we've probably encountered that a little bit if anyone's done anything with like the math library or math module. But the powerful aspect is inside of this person object, I can now include greetings instead of having to redefine these methods. And it's as if, or very close to as if, this person, whenever I create a person, will have a hi and bye method on them. So in this example here, I created Jorge, person.new, and then I can call hi and bye off of him, even though my person class never defined hi and bye. So he has hi, and he has bye, and that works just fine. Now, as he said, though, there are some differences between a module and a class, and those are important to know. That includes if I tried to greetings.new, let me try and create an object from my module, it's not going to allow me to do that. You create objects from classes. Modules are this sort of static definition that you can mix into something and use. Also, modules, I don't just do the dot syntax here, right? Do I use the colon syntax?
Mm-hmm. Well,
is that only for, that's only for constants?
Right.
I don't know if I'm gonna have access to this or not. I'm only gonna have access to those when I've mixed them into something?
I think so.
Okay.
I'm not entirely positive, to be honest. I think so.
Yeah.
Yeah, because it's just a module, it just contains the methods that you want to add to something, right? That's the only reason that they exist.
Well, they have one other purpose that you'll encounter. And I don't know if we've used them, but for example, I don't think you do include here, do you, how do I just bring in a module, or is it already here? Math, like pi, okay, it's already there. So here's another use of a module. Math in Ruby is a module that's built into Ruby. And you can put constants like pi or some other things onto a module, and then just sort of have general access to them. So if we went and looked, let's look up the math module for Ruby, and you can see, okay, it gives me access to some constants. And then it does give me access to some public class methods. That's a little weird, but it gives access to some other items as well inside of the math object that you can just access directly and use. So that's another use case for modules, although it's much more common for someone who's creating libraries than it is for somebody who's writing code to use them in that way. If you're thinking about modules, what makes them different? Why would we use modules versus inheritance? A lot of the value from modules comes in being able to share them between things and being able to isolate your code in small self-contained concepts. So this is a good example in a sense because we could put other greetings in here. And then we've isolated all of these greetings into a module together so that it's sort of logically grouped. Oh yeah, I've got different types of greetings that go together, and that makes sense that we should keep them together. And then people can add in greetings and have access to all that functionality without too much complexity. It also allows you for some pretty flexible functionality in terms of mixing stuff in, where we could have another module that maybe we've got different types of greetings. Maybe we have someone who's particularly friendly, and we've got very friendly greetings, and we've got other ones, and then you could include them in different types of people flexibly to allow that sort of mix-in behavior. And you could include more than one module. So you could also include, if we had, I don't know what else to describe here for a person module, a module of sayings per se, I don't know. F, like silly joke, and then I got nothing. I got nothing. Actually, so last night I was randomly at Target and I saw a llama lamp. Yeah, it's weird. A llama lamp. It's like, and I decided they should make a llama lava lamp. So that's a bad joke. You could have other modules and add them into. You're gonna let me mix it in afterwards? I think so. So you can include other modules into your objects, more than one. It allows you to isolate a lot of these concepts into groups of logic that make sense together, but that then you can mix them into objects, and let's see if it added it to you. And now you get that functionality.
I guess that's the other difference, right? That you can have several modules included, whereas inheritance you can only have one parent.
Yeah. Yep. In some programming languages, you can inherit from multiple parents. You can have what's known as multiple inheritance. In Ruby, you can only inherit from one object. So you can only have, if you're looking at your inheritance chain, you've seen this on a lot of things, where you've got fixed num, and fixed num, I'm awful here, inherits from integer, right? And integer inherits from, I don't remember, and so on. But there's only one object in your inheritance chain. Whereas if you want to get behavior, multiple types of behavior, and mix it into your object in a very flexible way, how would I be able to do that if I can only inherit from one thing? That's one of the powerful things that modules gives you, is the ability to bring in a lot of different functionality. This is definitely something that as you continue on with Ruby programming, you're going to encounter a lot. A lot of logic comes in through these modules, and it can actually sometimes be very confusing when you encounter it, because you'll have a class that looks like maybe it does nothing or almost nothing. You'll have like this person, it looks like he has nothing in him, and it's nothing's going on. And you'll encounter this where you've got this class that looks very, very simple or very basic. It's just including some stuff, and yet, boom, here's all this functionality that came out of nowhere. And that's because it's defined in the modules, it's defined in the superclasses that it's inheriting from, and all you're doing is changing one or two small things or defining a few basic differences between it and what it's inherited, and then that's working. Now, one of the important things about modules here is they act a lot like inheritance as well. So if now my person, I define a silly joke, and let me come up with something really bad. What? A parent? Yeah. When it becomes a parent? Yeah. That was a bad joke. I'm struggling.
What is that joke about the pretzel?
There's this. I have no idea. I'll do a programmer type one.
What did the buffalo say to the son who left college?
I don't know what.
Bison.
Okay, good. Yeah, see, that's good. But what you're going to notice now is if Jorge tells a silly joke, that's the joke he told. Can anybody explain why that's the joke he told? And you probably not at this point, but take a guess. Not exactly. We'll go over here and we'll board this out. We'll show it on the board because modules, again, they act somewhat like inheritance. So let's create our objects here. We have a person. And over here we have Jorge. And then this person inherits from really nothing, object over here. But we'll have it in the chain anyways. But it also mixes in the behavior from, what is this one, sayings. And it also mixes in behavior from greetings. In our greetings, we have hi and we have bye. And in sayings, we have our silly joke. And this behaves very, very similar to what we've already learned about with inheritance. And so before we had defined anything in person for silly joke, what happens as we called that method or sent the message, as it's called, for silly joke, when we did write a silly joke. Was it looks for the first item in the inheritance chain that is able to handle the message of the silly joke request. So we sent the message of silly, we want to do a silly joke, and it looks for something that can handle that message. So it looks in our person object, and it doesn't see anything to handle that message. So the next place it's going to look, and I'll write out this order on the board in a moment, but the next place it's going to look is in any mix-ins, any modules that got mixed into our person object. So it'll immediately go to, oh, sayings. Okay, well, I see that there's a silly joke here. So this can handle the message that I just requested, and that's why we told the joke. Now, once we've written silly joke here, we didn't per se get rid of the one that we had in our module. Instead, when we call it on Jorge, it looks for the first thing that can handle the silly joke. And it goes, all right, this person object. Oh, he already handled the message. Nothing else needs to process that message at this point in time. So it still exists on our sayings. It's still part of our object. It just doesn't get processed by it because something else handled the message first.
It's kind of like the random order who gets called.
It is. And right. That's a good way to think about it. And the order for this, I believe, I don't think I'm going to get this wrong. So the order it's going to check is it's going to check first on your object or your class. And then it's going to check any mix-ins to that class. And then it's going to check, you want to take a guess what it's going to check next? If it doesn't find it there, it's going to check your superclass. What about next? Any guess? If it didn't find it in your class or mix-ins to you, it's going to check the superclass, and then you got a pattern here. What?
Super. Eventually, when you do pull up the
Yeah, we have what? We've already built the pattern. We check our class and we check mix-ins to that class. Now we're looking at the superclass. What do we think might go here? You can mix into that as well.
Yeah.
So now it's going to check any mix-ins into your superclass. And this will be the way that it'll look for something that can process this message that you just sent. And it's going to continue down the chain, yeah, until it can't find something that can handle it. So now we can, let's go ahead and create another class. And this class will be, this class is going to be a programmer, and he inherits from a person. And we'll just go ahead and, in this class, it's good. Programmer.new. All right, so we have one. If we do Jared.silly joke, we're going to tell the buffalo joke. That's a good question. I don't know. Let's find out. Let's open up our person. I was wanting to know this anyways. And let's do his silly joke again, right? Unfortunately, I have to rewrite it now. But I'll just copy this line. I don't know what's going to happen. Let's see. You need to put the parentheses around the super call here. You need to, I believe you do, because it needs to know that you're invoking a function. Because if you didn't, then it could be a local variable named super instead, and it can't tell the difference. So even though you're not passing any parameters, I think you have to do it to distinguish. That happens sometimes in Ruby, where you need to use parentheses, even if you're not passing parameters to something, so that it knows it's a function call. Okay. So I think you have to do that. I don't know if this is going to work. I don't know what happens. Do you know what happens here? Hey, look, it tells both jokes. So it does see the mix-in as your super. It's just still, basically all that super is telling you is go down the chain. So that's interesting. It didn't actually go down just to the super class. It looked for the next, essentially, when you call super, you could think of it as not necessarily going straight to the super class, but looking for the next thing that can process that message in your chain, right? I wasn't sure if that would work or not. So now,
and it adds it, like if you have something inside the method, extra functionality, and it adds it on top of the previous method, right?
yeah.
Yeah, you have
Yep.
code, and then it executes that method.
Yep, because this is the same thing as calling the method. It's not replacing what you did, it's calling down into the one below. So it's just calling down to the super after it's already done the other code that you have up here. So now we can do, we already did a silly joke for me, but let's open up the programmer class again. And what I want to do here. Was it import? Is that right? I can't remember my syntax here. Include, thank you. Now I'm going to include sayings in.
Isn't it already person that's saying?
It does. And I'm going to end, and I'm going to do Jared dot silly joke. And it didn't work. At least not what I was expecting.
What were you expecting?
Which I left it open because I know what happens if you include something multiple times. I just wasn't sure what happens if you included it in different levels in the inheritance chain. What I was imagining was that since I included it directly in my programmer object,
Yeah.
that's going to look at the mix-in off that instead of calling my superclasses silly joke method, which calls down into it, right?
Yeah.
If you go back and you did the silly joke without the super, and then you include sayings, and then include the llama.
So I think, and this is part of the behavior of an include, is if, for example, we'll go back to our person, and we'll do this step again. If we include sayings, and then we include greetings, and then we include sayings again, it's not actually going to have included sayings the second time since it's already included it once. This one gets ignored. And this is important also because I said it's going to look like we've got our inheritance or the order that we look for items here. Well, what happens if we have two mix-ins that define the same method? So what if both greetings and sayings defined silly joke? What it's going to do is look starting at the bottom and working its way up from how they were included. So since originally sayings was included seconds, in a sense, we added it later, it'll look for it in sayings before it looks for it in greetings. it's going to work its way back up. And that's why it could be important that it works this way for the include. Include sayings isn't going to get included a second time. So if your goal was to override some version of greetings, but you've already included sayings, it wouldn't work. It's not going to work the way that you expect.
There's so much inheritance between the two, base object to this object.
Right. I'm pointing that out because I think that's why when I imported or included sayings into the programmer, I did it on a programmer, right?
Yeah.
Yeah. That when I included it on a programmer, it didn't change my silly jokes.
Yeah.
Is because it looked at my inheritance chain and said, oh, this has already been included in this chain, so I'm not going to include it at this object level. It's already part of your object. So I think it was the same logic.
Yeah, so you couldn't change the ranking of all of
I couldn't change the ranking just by including it at this level as opposed to at a lower level that I had already included it. Yeah, I'd have to double check and really look into it to confirm that, but I'm making this up on the fly. I looked at what I just did, and that makes sense to me from a programming perspective based off what I know about how a module works in Ruby. Like I said, this is a very, very common pattern in Ruby programming, is working with modules. You're going to see a lot of module-based programming, especially if you go on to Rails. There's going to be a lot of stuff where you include something at the top to give a whole bunch of functionality into an object that it wouldn't have had otherwise. And on top of that, you're not just including modules that you wrote. You're usually including a module that somebody else wrote. And it can literally completely change the way that your object will now work.
So for modules, do they have to be in the same file? Like how can you access the integration?
They don't have to be in the same file. Do you have to import them at the top otherwise?
Just require.
Require? Yeah.
Require, and then you can pass it the path.
So I'm going to give you guys my cheat sheet here because I'm the least prepared that I've been for any of my classes today. So this is a page I really, really like a lot of the documentation from. I'm going to send it out at the end of class, but I've used them to help me out in different places here. Let me jump down here. Modules. There are, it gets confusing. There's actually 4 different words to include stuff in Ruby, but require and include are the ones that we're talking about here. So you need to require a file to get the module in at the beginning, and then include is what allows you to mix it into an object. So if we were to write this out as separate files, which we can do very easily. Let's go up here, we'll create a greetings.rb, and we'll make it a module. Then we can add in a couple greetings. And now let's create a person.rb. And we're going to require greetings. I think this is the right syntax. And then
Do you include?
I need
We'll see. I'm not that worried about we will find out. Oh, I didn't do anything with the person here. Let me create a person. See what happens. Yeah, so it couldn't find it. So I'll tell it, look here. Remember we talked about the command line before? That's just command line type syntax to tell it, look in the current folder. / is the folder I'm in right now. .. means go back a folder, go up a folder, right? So there we go. You just need to require it, and then you can include it in once you've required it into your file.
And that's for like any file, like if you need to include a class or you need to include something else. Right?
Yeah.
It's not module. I guess it's not modules.
Yeah, that's not tied to modules. That's just a way to get code into another file. So usually, and we haven't done a lot of that here, but if you were writing a more complex program, you might have like, say, a main.rb file. And that file is requiring a whole bunch of your classes and objects in. So that
I should have doing the album thing, that I should have had an inventory as the actual hash. And then required hash.
Yeah, I mean, eventually you'll start seeing, like, that's what Rails will do. If Rails will actually have conventions on how to separate your files so that it all works together. So the idea is that your files are kind of conveying what the concept of the code contained in it is.
Yeah, I want us to, we may not talk much about scope because I won't have enough time to go through more tic-tac-toe examples. So I think I'll break stuff out. I'm going to take our tic-tac-toe we have right now and break it out by files so that you can see a little bit of that. I believe, I'm going to try something here. This is going to get into a territory I don't know if it works. So I'm going to change my person here. I need to fix this. Hold on. That should work there. So let's see if this works. I'm doing something crazy here. I think it will. So a little more interesting aspect of modules there. Did you get the tricky little thing I did there? I told you modules don't really have instance variables. Modules aren't classes or objects themselves. But when that module gets mixed in, you do have access in it to the instance variables of the object that you're mixed into. So if you know, for example, that these greetings are going to get mixed into objects that have a name instance variable, then you're able to use that inside of that module, even though nowhere in here did we define a name variable.
I guess that's both the power and the danger of modules, right? Like you have to understand the contract between.
Yes, you have to understand the contract, because if you look at this, it's not clear. Well, let's say you don't look at this. Let's make it more clear. Let's say instead, a lot of times when you're looking at code, what you see is something more like this. Oh, this greetings module has a hi and a bye method. It might not be clear that it's expecting the object that it's mixed into to have a name, and that that's an implicit requirement for this module. So then if I mix this greetings into something else, let's do a class animal. And then we'll create one. And I'm not thinking of like an animal here. I'm thinking of like Animal the Muppet. No. Animal! And if I do animal.hi, oops, we got nothing there. My name is, it's because we don't have a name instance variable that it can actually print out inside of that module code.
So it's really what it says. My name is Nil, right?
Yeah, it's saying my name is Nil, but Nil prints out as an empty string.
Right.
So it prints out as an empty string. But that is something you can do. And you can even, and this is going to get really crazy here, you can even, I believe this works too. Let's see. At, I'm going to spell it wrong. How's it spelled? Hasta la vista?
Yeah, that's it.
Yeah, yeah. All right, it's going to get crazy. Let's see if this works. Oh, I'm not printing out by. All right, now I just printed out this hasta la vista. But I told you just a minute ago that modules don't have instance variables. And yet, it looks like I created one right here inside of my module and then used it elsewhere. The trick here is that modules do have access to the object that they're on. And when you're creating something like this that looks like an instance variable, this by saying, it doesn't create it on the module. It actually creates it on your object. So it adds the instance variable to Jorge here by saying it's not part of the module itself. And then it has access to the instance variables on them as well. I honestly don't know how frequently that's used. I'm pretty sure in Rails they do it a fair bit because you end up with sort of magic instance variables that show up when you mix in certain things. Yeah.
Probably.
See, this stuff starts to make sense, right?
Yeah.
You think about some of this magic, and you start to go, I get what's going on in Rails. It's doing some crazy magic behind the scenes, adding things in. No wonder those suddenly show up and I have access to these. Where did they come from?
Yeah, that makes a lot of sense.
Right?
I didn't know that. Like essentially what the module is kind of like a namespace to have methods to show into your instance.
Yeah. Yep.
Okay. And so like if you were to do extend versus include, then you're showing those things onto the class, not the instance.
I'd have to look, but I think so. I'm not as familiar with extend. All right. I don't expect everyone, again, as I've said before with some of these last few concepts, to be 100% comfortable with the idea of modules right now. I hope that it's a concept that you grasp a little bit, that you're starting to think about now that we introduced it, that you'll continue to mull over, and that as you continue on, it's going to be something that you'll be able to leverage and understand better when you encounter them more and more, as opposed to needing to write them out yourself at first. Because one of the first things you'll do is see a lot of code that has this sort of magic behavior, a lot of magic modules showing up all over the place. And if you understand a little bit about what's going on there, that's going to help you out a lot in terms of grabbing an understanding of Rails, grabbing an understanding of other code that you work with. Now I wanted to take, we got a little bit of time left, and let's try and, this is going to be crazy. This is live coding. I don't know how well this will go, how smooth this is going to be. Always goes well. You never run into the demo gods problem where they punish you. So let's go ahead and build on our tic-tac-toe example. I should have sent out a homework assignment for this. I just failed to send out something for people to work on. So we'll try and live code some of this out, see if we can build on it more and get something closer to an actual game of tic-tac-toe going on at this point in time. And we just showed how to break stuff up into different files. So I think it makes a lot of sense for us to do that at this point in time into the way that you would probably write this. So you'd probably have a square.rb and a board.rb file, instead of just having everything directly in this tic-tac-toe. Then we're going to take our square class directly out of this and put it in our square.rb file. And we're going to take our board out of this and put it into our board.rb file. We just introduced require. So we know how to require. Yeah, sure, use different quotes, Jared, because that's good. We just introduced the concept of requiring another file in, right? So now if we were to look at what we have for the stuff that we'd previously written, there's some real pros and cons, but I think way more pros to splitting our code out this way. One of the big pros is I don't have to look at this square or this board to understand too much of what this file is doing. It's creating a new board and asking it to show itself. And when I look at the square, I don't have to necessarily think about the board or see that code and try and understand what's going on with it. And when I look at the board, well, I don't have to try and understand what's going on with the squares as much. So I can reason about my code. Let's make sure this works, because maybe it doesn't, I don't know. Looks like it's still working. But one of the big powers of splitting out like this is I can now reason about each portion of the code separately from the other portions. So let's go ahead and tackle that. Let's move on. What might be the next thing that we want to do with our tic-tac-toe board? Well, we're rendering a blank board. Let's say that a square should be able to be set to a value. So we want to be able to set a value on a square. We already have our value object. Actually, we defined it as an accessor, so we sort of can do that right now. We could, if we wanted, wrapper it with some extra logic to make it easier. Like we could do, instead of accessing it directly in this way elsewhere, We could have, I don't know what you would do, set x.
Yeah.
Or you might do your, let's do it this way so that we're using our accessor. You might have a set O. And this is where you get into stuff where there's not a right or wrong answer necessarily for how to do this. I don't know if we're even going to use those. I'm just putting some examples up there right now as I'm trying to think through how to do this. And then the question is there anything else you need on a square? Probably not, right? So I feel like the square as a concept is pretty complete. So let's step up and think about our board a little more. For our board, what type of actions do we need maybe from a board level? What can't we do yet with our game? Well, we really can't set. There's no way to play, right? We can't play. All we can do is render a board. We can't actually change the values. I mean, a square can change its value, but we don't have some higher level way to change a value. There's no way to win, but that's going to be probably going to skip over that for the time being, just in terms of complexity. So let's start with the ability to.
We want to get user input and allow them to choose which square that they're putting your input into. Right? That's the key thing about Citrix. So you're going to put something in it, you can be able to pick your input in there.
All right, sounds good. So let's move all the way back up. Let's step all the way back up here. We've shown the board. Let's do something like put. I am so consistent with my quotes. I guess I do want to double quote this.
A multi-line, they like do it too.
What?
A multi-line block say or do it.
Do an end.
Yeah. Loop do.
Loop do. Ah. So let's, all right. We want to play a game. So tic-tac-toe, I mean, we'll break this stuff out more and more, but what's the first thing that we'll do? Player one, right? Player one chooses a square. And then I'm just thinking through what happens in a game, right? Player two chooses a square. And player one chooses a square. I'm gonna write this out just for a few real fast. Player two chooses a square. Right? So after three choices, it's possible somebody won the game. Just thinking through if I were, this may not be the same way you'd write it everywhere, but you're going back and forth to choose a square. Okay?
So they choose a square first, then based on user input, they put in X or O, it will pull up that set X or
Sure. And that's why I said, I don't know if we're going to go this way or not. So these look Player 1, player 2. Oh, it's an awful lot like some sort of object. Sort of looks like an object of some kind, right? All right, let's create a player here. So class player. Are you gonna have anything? They might have a what?
Name.
Maybe they'll have a name. They're definitely gonna have I'm gonna call it their mark.
Or like 1 or 2.
What?
You mean like whether it's player 1 or 2?
Yeah, but you know, I'm gonna call it their mark. And you know what? It makes sense to, no wait, what's it called? Reader. There we go. It makes sense that the mark is only a reader. They can't change their mark after they've been created. All they have is their mark. So we're going to pass their mark in here. At mark equals mark.
Should we have the logic determine if your player 1 have the class do that internally? Set the mark internally?
We could. I'm just going to do it this. I mean, we could do it that way. I think I'll do it this way, although I don't think there's a right or wrong. So, well, we created a board. Let's create some players. Player.new x. All right. Well, there's one other thing we're missing. We need to require our player. So now that's interesting. It sort of looks like maybe I don't need, again, I'm live coding this. I don't know which route I'm taking. Maybe I don't need on my squares like set X or set O, because I've got my mark for my player. So when they take an action, they use their mark and that determines the value that was there. That sort of works. I don't know. So we have access to our value for these. So yeah, I feel like we're getting somewhere there. What do you think? Let me know if you think anything's crazy or it makes more sense to go a different route.
I don't think it's good.
Just sort of, yeah, we're just sort of making it up as we go. All right, so let's come back down here. Player 1 is going to be able to choose a square, but first we need to tell them.
Maybe on square, you just took out those 2 methods.
Yeah.
And you leave the respondent method saying set value and you pass the mark. So that eventually player can pull on the square and set the mark that the player has.
Yeah, well, we do have this as an accessor, so they should be able to do like square dot value.
And pass the mark as the value.
Yeah.
Okay.
I think. We'll see how it goes.
Yeah.
So we're going to want to prompt the player to choose a square, right? But choose a square to play in. And then they're going to be able to choose. We need some way for them to choose a square. I don't know how to do that easily. Any good idea? on what to do here?
How is the board?
The board ends up looking,
I played SWAT's label as B.
gonna comment this out. The board looks like this right now.
So should we tell them, like, give a name for each spot in the board and tell them to choose?
You can do like an array of arrays, right? Yeah. 0 row, 1 row, 2 row, and then inside of each of those arrays you have the position 0, 1, 2. So you pass it in first, you pass in the row, and then the second argument is
You could do that. Trying to think through it right now is, got an idea. This is where there's not a right or wrong answer. That was initially what I was thinking. The same as you. I was thinking the same way as you. What if, and this is a what if until we've put an X or an O there, each square has a number? Just 1 to 9. And then once you've put your mark there, then it doesn't show the number.
and there's always some, okay.
I don't know. No, I'm just being crazy here.
It doesn't even have to show the number, right? Like you can just have property of a number, and then that's what determines where that square is.
Yeah, it could definitely have that, and not show them. We could show them at the very beginning. We could just have them as a property. Just
Okay, yeah, that makes sense. So like they see the board 1, 2, 3, 4, 5, 6, 7, 8, 9, and say user, type in the number of the square that you want to update.
yeah. We could do it in a few different ways, right? So when we show, we could show the board, but we could also show the reference or something, right? We could add another one of these show reference that instead of show board. And maybe that works a little differently. So maybe, live coding this, right? Maybe we want another property on this guy. This one's also going to just be a reader. And that's going to be its position. And when we initialize, let's pass in a position. Because a square really shouldn't know what its position on the board is. A square is just a square. And the board should tell it what position that square is in, if that makes sense. The board says, oh, you're in this position. All right. Let's go ahead and do that. And now let's add another show here. Def show reference. What you'll see is I'm sort of reusing logic here between show, reference, and show. They're going to look very, very similar. So I'm going to get lazy for a minute. I'm just going to copy this over. I'm going to change these three. Say show row reference instead. Let's go ahead and create that. And this is going to look a lot like this. Oops. except instead of the value, I want to get the position. Let's do this again. Right. Now when I create my squares, I need to pass in. I'm so lazy. I don't want this to be named because then I have to type it in every time. So I'm so lazy, I got rid of that. 1, 2, 3, 4, 5, 6, 7. I don't think we're going to finish this in class today. So I'm probably going to finish this in our next class. I'm going to keep going until we're close to time. But I can already see, as I start working on this, I begin to see patterns and things that are going to cause me problems.
Right.
So as I'm writing the code, I go, uh-oh, did anybody notice something that's going to be a challenge now? I just wrote this out. Here's my squares, but okay, somebody's going to give me a number. How am I going to know which one of these to set the value for? That's going to be a little bit of a challenge. Somewhere along the line, I'm going to need a way to get back to these, and I could hard code them all, but I'm probably going to refactor my code, rewrite it, and change the way it's written so that it's easier to do when I encounter that problem. I can look ahead. I've got a lot of experience with programming, so I can look at it and go, that's going to be a problem in the near future, but I don't need to solve it just yet. I'm going to keep working on what I'm doing. All right. So let's test this out. Let's try and do a show reference and see what happens. Probably have bugs. Wrong number of arguments, given 1 expected 0. Oh, see, I didn't define my method right. All right, string can't be coerced into fixed num. That's the difference of right here. I need to do a 2s on these because I was setting integer values. And the code was trying to convert my other string items into the fixed num instead. All right, it's looking good now. We've got a reference board printed out here. Undefined method put. Yeah. There we go. We're starting to get something. Looks like it should work. Again, I'm just making this up as I go along, so.
So you have now 9 square objects.
I have 9 square objects, but they're not in some nice array altogether, unfortunately. That's where I said this is going to be a problem in referencing these. I didn't just create one flat array of square objects. So it's a little bit of a challenge. But that's fine. We'll refactor our code. We'll rewrite it so that this works. So anybody have an idea of what we should do next? Now I've got some sort of reference. It looks like we've given people a way to choose a square, maybe. So we want to, let's ask the players one at a time to choose a square. So I'm going to set a variable here. I'm going to call it player turn. I'm going to set it to 1 first. So I'm just going to set it to 0. It's going to be a little weird, but player turn plus 1. So I'm saying player turn plus 1, choose a square to play in. Maybe I'll print out my reference at the top. Again. It's the number of each square. All right. Just print that out right then. I don't need to show my board initially. But I'm probably going to want to show it maybe at this point. This is me being lazy. Just to give some spacing. So let's show the board. How do we get user input? We've been doing this for a long time. Gets. All right, so let's do a value equals gets dot chomp dot. We want them to enter an integer, so $2i. Sounds good. Let's put some very basic logic in this to make sure that they're entering something valid. If I is greater than 0, do this, and I is less than 10, or let's flip it the other way around. If I is less than 0 or I is greater than 10, and we know that there's a problem. That is not a valid square. Can you do next? Should work, right? Oh, yes. We could also just change this. Greater than 9, less than 1. Right? There we go. And I only did it that way because I feel like it's a little easier to read compared to what our board's going to be. So they get to choose a position. Now, what are we going to want to do after? Okay, let's assume that they have a valued value now. So let's set it, right? So board dot, uh-oh. We don't have a way to set the value yet, right? Okay. Yeah. So let's go back to our board. Let's add a method here of, what should we call it? I don't know. Set mark. Sure. This is going to need to take some arguments. We're going to need to take into our set mark method in order for the board to know where to set a mark at. It probably needs 2 pieces of information. Any ideas on what those are? Let's go over here and look at what pieces of information did we just get? Ah, I'm sorry. No, it's fine. Call me out. Am I doing it elsewhere?
Yeah, on board.
Oh no, set mark, huh? I'll bet I did it in.
I think you're good so far. So we'll do that.
All right. On my player, yeah. It's fine. It's something I've so ingrained in me, even though I don't like it, honestly. I prefer more languages use this because I think it's easier to read. All right, we've got our board. If we're going to try and set a mark, what type of information might we need to figure out how to set that mark?
So first, you capture the square, which you got from the get.
Our position. All right. So we know to set a mark on a position. That's great.
And then you decide what the mark is going to be. The mark is going to be the player's mark.
And then you need the mark, right? What type of mark am I setting? All right. How can I do this? Could I put these, I mean, I could put these guys in an array. But can I reference something dynamically between player 1 and player 2 to get the right mark? Jorge, do you know?
There's many ways you can do it, right? You player one will always start, right? So at the end, you can switch the player through each loop.
I like that. Let me just, I'll even get rid of this. So then we can output the name, right? The name would work here. So if I did, oops, player.name, and if right here I started and I did player equals player 1, is that going to work the way I want?
Yeah, but I don't know if player doesn't have a name, does it? You go to player, the player.
It doesn't. I wasn't sure if the name, can you get the name of your actual variable? I'm going to try something crazy here. I don't know if this works at all. Ooh, you have disappointed me. All right. Come on.
You look for the class name, you do the class name.
I'm looking for my variable name.
Right.
I'm trying to be lazy. I don't have to be this lazy, but I'm trying to be.
Are you talking about the mark? Is that what you're looking for?
No, don't worry about it. I won't be that lazy. I'll do it. I'll do it more appropriately. All right.
Yeah, I think I just don't understand.
When I was trying to output, like right here, like player 1, it's your turn. Player 1, choose a square to play in. I'm trying to get the name of my variable of player 1 or player 2, whatever variable I had assigned to the player, but it's not going to work.
Okay,
And that makes sense that it wouldn't. I could give them names, like you said.
gotcha.
Probably makes the most sense, actually. I'm just going to make this another reader, so I'll just add it here. Do I need a comma between them? I think I do. So let's add names. Player 2. Don't need this. I'm sorry, I'm sort of flying through a little bit here. Player.name. So then here we also need to pass in our player.mark. And it should be able to set it. And then one last thing we need for a very basic loop, we need to change our player. I need to toggle between them. It's the best way to toggle between two. I can do a basic if. If player equals player 1, player equals player 2, else player equals player 1. All right? So let's, oh, we didn't finish writing out our set mark method here. This is where I said we're going to get tricky. Because we've got all these nice numbers, but only internal to these squares. We actually have like 3 rows. So we just got to position in a mark. Well, that's somewhat tricky. You have to look in like, oh, if it's 1 to 3, then get the item in the array for the first row and set it. If it's something else. So instead what I'm going to do,
Yeah, like you can, you want to put them in an array so you can iterate.
I'm going to change this around. We're going to put everything in an array of squares all together, which means we're going to have to change the way that we output them. Am I allowed to write my stuff out this way? I think I am, right?
The latest way would be to put those 3.
Put it in a loop.
No, you could flatten it, right? Like so, go back to where you were.
Oh, dude, I can use a.
Yeah, just put the 3 instance variables in an array, flatten that, and there you go.
Oh wait.
So it's like all squares, right?
Oh,
all squares.
dude, you're doing some crazy stuff now. Stuff I don't even do. Equals. I see what you're saying.
Yeah.
She's doing something crazy here, so.
Yeah, sorry.
No, it's cool. I'm gonna rewrite it and make it easier though, actually. But
But you see what I'm saying, though, right?
oh yeah. Then we're gonna do flatten, right?
Yeah, I think so. I think that does it.
It's crazy,
Yeah.
right?
Yeah.
He's writing some crazy stuff. We're gonna do it a little differently here. We're gonna do squares. All right, equals an array of. Can I use a? I don't think I can just use a range here.
Ready for what?
I'm gonna do it like this actually. Squares equals an array. And then I'm gonna do a loop. And I can do at each number do, right? That's squares of dot push.
You need another dot range.
Do I? To get 2.9? To include it? All right. New. And we're going to create a new one, which is number. That should create a simple array of squares, right? Now what we're going to do is we're going to change the way these show and show reference methods work. And this isn't actually too hard. All right, to show a row, what we're going to do is go to @squares. And we're going to get 0 to 2. Is that going to work?
I think so.
You think so?
Yeah, I'm not 100% positive. I mean, the range will work. I just don't know if it's 2 dots or. And I think it's square brackets instead of.
Like this?
Yeah.
All right. You guys are encountering a lot of new stuff here. So 3, 4, 5, 6, 7, 8. Yep. Let's see how this goes. No, because I'm referencing, it's the tricky part. They're numbered, they have values of 1 to 9, which I want them to have, but this is an array 0 indexed. So I want to get 0 to 2, 3 to 5, and 6 to 8 for these, right? And then I really just need to do the same thing. Just going to copy this. If this works, it works. If it doesn't, yeah, we'll find out. This is a lot of live coding. And in a language that I don't write every day, so it makes it much more likely that I'm screwing something up here. All right, let's see what happens here. I'm going to comment this stuff out still to see if our other stuff works. I'm going to add in my board.show here to make sure everything's working. Unexpected keyword do block. It didn't like this, I think. Where did it say the error was?
Oh, no, it's a syntax error.
Oh, this is backwards, right?
Yeah.
All right. You guys seeing it all blow up live? Uh-oh, we're at time now. So it couldn't find positions for these guys because when I reference these, all right, it pulls a chunk out, da-da-da. Let's just create a new array. What's it gonna do with that syntax?
Let's look at squares. How does add squares look like?
Yeah. All right, so I got square objects. 6, 7, 8.
You only have 8, so the 9th one that's the one that's walking up.
I'm gonna try this with the syntax instead. Yeah, it got me 9. All right, that got me something. So this isn't working, so I'm gonna do a puts row and see what I get here. Now you get to see someone live debugging. Let me get rid of my puts as squares here so it's not so spammy. All right, I only got 2. That's because I was using the triple dot syntax. So let's get rid of that. See what happens. Feeling good now? All right. Get rid of this, test it out again. This, by the way, is the coding flow that you typically have when you're doing programming.
Yeah.
It's like, no, back, forth, back, forth, back, forth.
Yeah, I guess that's why testing exists.
Yeah. All right, well, we've hit time. We didn't quite get everything that I wanted done with this yet, but we're getting close. We can almost play our game. I'm going to go ahead and finish it up in the next class. After we're done, I'll probably not cover any of the logic around how to check and see if the board, if somebody's won. I'm just going to write that out, and it'll be magic logic that I'll give to you guys afterwards so you can look over it. But we'll walk through the rest of the logic of playing through the rounds and testing that out. I just don't want to make people commit to staying here longer while we try and live code through this. But I do think this is a very useful thing to see happening. Working through a problem, working through something more complex, knowing that this doesn't come instantaneously to anybody. It takes thought and refactoring and, oh, I didn't do it right the first time. Maybe I need to change the way I thought about how that was structured to make stuff work for you.
Yeah. Usually by the third time,